video is about decimals. Let's look at a decimal. So we have this number 123.456. There are three parts to this number. You have the whole numbers. I'm going to put in green. You have whole numbers, right? You have the decimal part. And you have the decimal point. Right? These are the three parts to a decimal. Now this place here, this place is called the tenth. This is called the hundredth. This is called the thousandth. This is unit, is 10, and this is 100, and so on, right? Now the reason we don't have a unit is because 0.4 can be written as 4 by 10, right? 10, so it's 4 over 10, or a tenth is 1 by 10, right? So that's why this is called the tenth, this is called the 100, because 0.05 is going to be 5 by 100. To convert into a decimal into a fraction, we take 0.679. Okay, for example, count the number of decimal places. That's 1, 2, 3, right? We have 3 decimal places. So write down our number 679, ignoring the decimal place, and we will put 1 followed by the total number of decimal places. So zeros, 1 followed by zeros with the total number of decimal places. So 679 by 1000. If we take another number, 0.124, right, we get 124 by 1000. Even if it's 0.0240, that's still 124 by 1000, because if we had to include the 0, then we have to include another 0, and these zeros cancel. So we get 124 by 1000. Now this is not in the simplest form, and in IGCSE all examinations you must leave your answer in the simplest form. So we divide this number by 4. So 124 by 4 will give you 31. This will give you 250. So the simplest form is 231 over 250. Right? Now let's look at doing operations on decimals. Now in IGCSE we follow BODMAS. This is brackets, right? Order. This is division, multiplication, addition, and subtraction, right? So let's look at the DMAS. Now for adding two decimals, let's take 0.153 plus 0.379. All you have to do is add them up place by place starting from right. So 3 plus 9 is 12, there is 1 carry forward. 5 plus 7 is 12, plus 1, 13, there's 1 carry forward, and 1 plus 3 will give you 4 plus 1, which is 5, and you get 0.532. Pretty straightforward. Now let's look at subtracting. 0.763 minus 0.4808. Now you might notice that there are 4 decimal places in the second number and there are only 3. In that case, you add a 0 at the end, so there are same number of decimal places. We'll do 76304808. Now we have the same number of decimal places, right? Now we subtract normally. 0 minus 8 not possible, so we borrow 1. 3 becomes 2, 0 becomes 10, 10 minus 8 is 2, 2 minus 0 remains 2, 6 minus 8 is not possible, so we borrow 1, 7 becomes 6, 6 becomes 16, 16 minus 8 is 8, 6 minus 4 is 2, so we get 0.2822. Again, quite straightforward. Now comes the tricky part. Multiplication and division. For these two cases, there is one rule of thumb. Okay? The rule says that the number of decimal places in the factors is equal to the total number of places in the product. Okay? The total number of places in the factors is equal to the total number of places in the product, right? So let's take two numbers, 0.2 into 0. Actually use a different color. So let's take two numbers, 0.2 times 0.8. Now you might think all you have to do is 2 into 8, which is 16. Okay, and then you might think the answer is 1.6, but this is wrong. The answer is 0.16 because there is one decimal place here and one decimal place here. So 1 plus 1 is equal to 2 decimal places. So 0.16, 2 decimal places. See, another way to think about it is 0.2 converted to a fraction. So this is 2 by 10. Okay, don't simplify it yet. 0.8 is also a fraction. Write it as a fraction, you get 8 by 10. Now you multiply 2 into 8 divided by 10 divided by 10. So now you can cancel, you get 2 by 10, you get, it becomes 1 by 5, 8 by 10 becomes 4 by 5. You get 4 divided by 25. Now if you multiply this into 4, you get 4 into 4 by 25 into 4, so that we have an easy division. 16 by 100 becomes 0.16. Now let's look at division. For division, same thing applies. So let's take 0.7 divided by 0.71, let's do 2 decimal places, divided by 0.89. Okay. First rule is there are two ways. You can either do it normally by counting decimal places and calculating, or you can use it in fractions. Okay, you can use fractions or you can do long division. Okay. So long division method is 0.71, 0.89. Now what you can do is, since there are an equal number of decimal places, you can cancel out the zeros. So you can cancel out the 0 point. So this can become 0.89, 0.89 becomes 89, 0.7 becomes 71. But in case it is 0.7 divided by 0.89, you cannot cancel the zeros. This is wrong. What you have to do is, first you have to ensure that there are equal number of decimal places. 0.70 divided by 0.89. Now you can cancel the decimal places, because now it will be 70 by 89. Earlier it was 7 by 89. See the difference? Okay, very important rule. So 71 divided by 89 is 0.78. Okay, rounded off. 0.78. Okay, because equal to 0.78 approximately. The other way you can do it is, right, 0.71 divided by 0.89. Right, so it is, you write this as a fraction. 0.71 is equal to 71 by 100. 0.89 is equal to 89 by 100. Then you divide, so 71 by 100 divided by 89 by 100. And now division is multiplication with the reciprocal. So 71 by 100 into 100 over 89. Then you get 71 by 89. 71 over 89 is 0.78 to the nearest 100th place. Okay, this is how you convert fractions and divide fractions. Divide decimals. How you convert and divide decimals. Now, when you have recurring decimals, okay, recurring decimals, they can be written in three forms. One is, you can write it as 0.3333 dot dot dot. Okay, where you show the pattern and then you put the dots. For example, if it was 0.14251425, you cannot, the right way to write this is 0.1425 dot dot dot, not 0.142 dot dot dot. This is equal to 0.142142. Okay, that is one way. Second way to write is 0.3 bar, and the third way is 0.3 dot. Same thing, but be very careful. If the same number is repeating, you cannot write 0.33 bar. This is wrong. You only write it once. Likewise here, you cannot write 0.33 dot. You can only write 0.3 dot. Otherwise, your decimal is wrong. So these are the three ways. Now, to write a recurring decimal as a fraction, they have an infinite number of decimal places. So you can't write divided by 1,000 or 100 or million. There will always be more numbers. So in that case, let's consider a number 0.2222. Okay, 0.222222. Now let this, we'll assign this to a. So a is equal to 0.22222. 10 times of a is 10 times of 0.22222. So this is equal to 2.2, right? Now if we consider 2.2, so let's consider 2.2. After the decimal point, the numbers are the same. 2.222222. After the decimal point, the numbers are the same. It doesn't change. So 0.2 also, after the decimal point, the number does not change. It remains the same. Now, if we subtract this, this will always be 0.222222 infinitely. This will also be 0.22222 infinitely. So when you subtract them, this will equal 0. Will be 0.0, and 2 minus 0 is 2. Will be 2. So using that logic, we are going to apply that logic here. So 10a, right? This is 10a. Now we're going to subtract 0.2. This is a, or rather minus a is equal to minus 0.2. So 10a minus a is 9a. 2.2 bar minus 0.2 bar is equal to 2. So a is equal to 2 by 9. Simple. 2 by 9 will give you 2 by 9 will give you 2 infinitely. Now this is the best way to estimate the value, but it's not very accurate, because if you consider the decimal 0.99999, for example, okay. Now we apply the same logic. X is equal to 0.9999, 10x is equal to 9.99. So 10x minus x is equal to 9.9 minus 0.9. So 9x is equal to 9. Now if you notice, but 0.99 is not equal to 1. So it's the closest approximation we have. But 0.99 can be approximated to 1. This is why we get this answer. Now let's consider mixed decimals. So if you have something like 0.1255555, so on. The problem is 1, 2 is not repeating, but 5 is. So in this case, we'll apply same logic. 1000x is equal to, if this is x, if x is 0.12555, 1000x is equal to 125.5, or rather we'll just use 100x. Let's just do 100x. 100x is equal to 100x is equal to 12.5 bar. So 100x minus x is equal to 12.5 minus minus 0.125. So now here we write it like this: 12.5555555, right? And then you have 0.1255555. So after this part, after this point here, it's all the same. So this will be 0, 0, 0, 0, 0. 12 minus 0, we will look at that later. First, 5 minus 2 is 3. 5 minus 1 is 4. Now we look at 12 minus 0, which is 12. So 12.43 we get. That is our answer, right? That is how it is going to be when you're subtracting. It's very simple. So 99x is equal to 12.43. Now we divide both sides by 99. So we get x is equal to 12.43 by 99. The only problem is you can't have decimal places in the numerator in the simplest form. So this will become 1243 by 9900. That is how we find mixed quaterary decimals. Next, we also have things like 0.121212. Right, we write this like 0.12, 0.12. Okay, so same logic will apply. 100x is equal to 12.12. X is equal to minus x is equal to minus 0.12. Right? So 99x is equal to 12. X is equal to 12 by 99. Now you have to keep this in simplest form. So divide both sides by 3. You get 4 by 33.